Hello everyone. We're going to learn about ignition systems today. We're going to go over how they work. Plan is next week to give you more diagnostic related stuff and work through that stuff for the rest of our class. This is going to go through all the different systems and how everything works. And I am going to include some animations that will be in addition to these that will give you an idea of what's actually happening inside the different systems. Okay, so let's move on. Ignition systems and all their pieces and wiring necessary to connect everything is used to distribute 40,000 volts or more. Really, our systems are 55, 60, 80, 100,000 volts AC. All systems apply battery voltage to the coil positive side and pulse the negative to ground. That really isn't true anymore. If you look at our Chevy Cruze, that one actually grounds the coil and sends power to it and breaks that side of it. So it's not all systems anymore, it's most systems, but you'll see both. When the coil negative lead is grounded, the primary, which is the low voltage side, right? That's the side that's being supplied by the battery. The primary low voltage circuit of the coil is complete and a magnetic field is created around the coil windings. Remember how we have wires that are wrapped around a million zillion times around stuff. When the circuit is opened, disconnected, the circuit is opened, the magnetic field collapses and it induces a high voltage spark in the secondary windings of the ignition coil. Remember, when the magnetic field collapses, we get a burst of AC voltage that comes out of that system. That's what your spark is. Early ignition systems used a mechanical set of contacts to open that ground side of the circuit. Electronic ignition uses a sensor such as a pickup coil and reluctor trigger wheel to signal an electronic module that makes and breaks that primary connection of the ignition coil. So this is your ignition coil, and you'll see that there's two windings inside. If you look, the ignition coil creates a high voltage spark by electromagnetic induction, right? That is having a magnetic field overlap another set of windings, and that magnetic field causes electron movement. Thus, without touching it, we're making electricity. Most of them, in fact, all of them have two separate electrical set of windings, right, of copper wire. So if you look at this coil, this is an old school coil. You'll see it, you have two terminals at the top, a negative and a positive, and you'll see both of them are wrapped around an iron core. Naturally, as you run current through a set of windings, you get a magnetic field that builds as that happens. If you look, you'll see the primary side is what the battery is connected to. The secondary side is the induced side. So you'll see the primary side in this picture is wrapped around that iron core 200 times. Our secondary winding is about 22,000 times wrapped around. When you look at those two, right, this is for a coil that would give us roughly 9,000 volts AC. Really low voltage on these old systems. What we have now is 80,000 volts AC. So we wrap that stuff around a whole lot more. Okay, so you'll notice the primary side is wrapped around 200 and the secondary is 22,000. So it's obviously the magnetic field on the primary side is going to be so much, and the one on the secondary side is going to be bigger. Notice that the primary winding is electrically connected to the secondary. Whenever we have a coil that has a positive and negative to it, right? A single coil coming out the bottom, one cylinder worth of coil, you'll find this type of relationship. You're going to see we have two different kinds of coils, and that goes all the way on up to your coil on plug style. If we have a single secondary port, which is up on top here, one single one, then this is the way that coil is wired up no matter what. Notice that it says other coils are true transformers, which primary and secondary windings are not electrically connected. We'll see that when we talk about the waste spark style coils that feed two cylinders with a single coil.